live streaming. Sweet. Okay, everybody, welcome to San Francisco CloudOps meetup number 7. All right, awesome. Thank you, whoever you are. You're keeping better track than us. As you know, we have our Twitter tag if you want to say nice things about this meetup. DevOps and Cloud also hashtags. I will do our obligatory announcement, and we're still looking for a senior cloudy, Python-y, Ruby sort of person to come do awesome shit on our Skybase project that will hopefully be open source soon. If you are interested in such things, talk to one of us who's not wearing a name tag, and we can help you with that. Let's see, other things I'm supposed to announce. I guess that's all the pronouncements today. Can't think of anything else. Am I missing anything? All right. Well, if I think of it, we'll do it at the end. I am really pleased to welcome Charity Majors here for our 7th meetup. Everybody say hi to Charity. I had to talk her into it. Charity's going to talk about chef things and parse things and cloud things and is going to share her wisdom of experience. My mother always said, smart people learn from other people's experiences, so hopefully she will make us smart. So, you all ready to go? Has everybody got their whiskey drink? Thank you to Charity for picking the drink. Oh, that's the announcement I was going to make. Thank you. We're also always looking for people who want to present. And one of the benefits of presenting is you get to pick the base alcohol. So today it was whiskey. If you don't choose, I pick the default of tequila, as some of you well know. I've gotten many of you drunk. Anyway, so now, welcome, Charity Majors.
Thank you. I just rode my bike here and got doored in fucking Market Street. So I am both sweaty and bleeding slightly, but it's okay. And I have my Manhattan and my backup Manhattan. That's right. That's right, medicinal whiskey. You are so correct. So, my name is Charity. I work at Parse, now at Facebook. For those of you who don't know much about what we do, Parse is basically a mobile backend as a service for mobile developers. So if you want to write an app, you can use Parse. We provide all of the core data, like push notifications, background jobs, server-side JavaScript code, SDKs, basically everything you need to build a fully featured app without running your own backend. We currently host about 400,000 mobile apps on Parse for about 300,000 mobile developers. I have a team of about 8 production engineers, and together we manage all the systems, all the deployment, all the DBA work, performance tuning, automation, basically everything on the back end. Our stack is entirely in AWS for the moment. We have a bridge to Facebook that we aren't fully utilizing yet. We're now in VPC. We moved, actually, over the last year from EC2 Classic into VPC, which is a whole different talk. Holy shit. We're really heavy users of MongoDB. We have one of the largest and most complicated MongoDB ecosystems in the world. We also use, we're fairly robust users of Redis, Cassandra, MySQL. Our main stack used to be Ruby on Rails, and we're in the process of migrating it over to Go. So this is basically a talk about how you fall in love with a tool, right? You find it, you're like, oh, this is the most amazing tool ever. It's going to solve all my problems. And then after a few months of really crushing hard on it, you realize it's just a tool. This is what we do with Chef. Like, it's really good at some things and really bad at some other things. And let me be clear that, like, in this context, what's good and what's bad, it's going to be different for every environment. Just because I'm saying, like, this thing really didn't work for us doesn't mean it's intrinsically bad. And if it's working for you in your environment, awesome. But a lot of the things that we tried to use in our use case ended up causing more problems. So like early days, like when I joined Parse 3 years ago, like I had never used Chef before, and it was so like love at first sight. Like I had used CF Engine, System Imager, Puppet, Salt, a little tiny bit of Ansible. They're all fine. Like I'm kind of a config management geek. There are good things about each system, but like I joined Parse. I was the first infrastructure hire, joining a bunch of software engineers, and they had installed Chef in a few places, kinda, and I was like, this thing a try before I just totally like tell them it's not working and I'm going to go back to Puppet or something. They're all snowflakes, like in their own special way, but like Chef was just so great. Like being able to execute your resources in order unless you explicitly tell them to do otherwise, coming from Puppet, that blew my mind. I was so happy. Having it be like actual Ruby instead of a shitty ass DSL that's only partially implemented. Anyway, so this was me. Yay! Like I felt like the most affirmatively positive feelings that I have ever felt for a piece of like configuration software. Like, don't get me wrong, like the learning curve for Chef was steep. It was steeper than other config management software because it's more software engineering-y than most other config management softwares, which are written by, you know, sysadmins for sysadmins. But I loved how much sense, and at the time, like 3 years ago, like documentation and examples didn't really exist. Best practices did not really exist, not in any real shape or form. Like I would be Googling around and looking for advice, like the right way to do things, and like things like Bookshelf were just kind of starting to come out, but there was a lot of really crappy things going on. But I love Chef. I loved that the community was really robust and, like, for lack of a better word, loving. Like, you would hop into IRC and ask your stupid newbie questions, and they were just like, yay, let us help you, which is really nice when there's not much out there in the way of docs or, like, any, like, really good examples for you to follow. So, like, here are a few things that I immediately stuffed into Chef. Like, when I joined, like, the source of truth for how services would talk to each other was a list of IPs that were checked into Git. Like, these are software engineers, right? They're like, this totally works. This is a great system. So one of the first things I did was, like, create roles for types of host and, like, generate their config files from Chef based on doing, like, nice searches. And this immediately saved me so much time, and all the software engineers were like, oh, shit, you can do that? It was great. Anyway, so like DNS, bootstrapping, generating all of our monitoring automatically, like provisioning, assembling RAID devices, generating config files, snapshotting, like everything. It was just like Chef everything. And like we even got to the point where I was like, maybe we can deploy our code using Chef. That's about when we started to sober up. We're just like, all right, we've chefed a lot of things. And we're starting to encounter some things that are not so great here. So in this talk, I'm going to cover really like two different things. Like things that we did with Chef that were totally reasonable that we did badly. And then things that Chef was just not the right tool for. Like, here are some of the things that were unforced errors, right? Like when I started doing this, I'm like, oh yeah, definitions, this shit is great. Oh yeah, let's totally use roles for everything, just put lists of recipes in it. Data bags, you know? And also, coming from like a not very strong software engineering background myself, I didn't really think of like, oh yeah, all my cookbooks should really have unit tests and continuous integration, and I did not, I forked cookbooks left and right, which is like a cardinal sin. Even I knew better than that. The problem with things like roles and data bags, by the way, is that you can't version your changes. Like, you know, if you're really trying to get to a place where you have infrastructure as code, you have to version all these changes. And roles and databases make that fundamentally difficult with most workflows. And like definitions instead of providers, man, this is before lightweight resource providers became a thing. We later learned that you should always use lightweight resource providers because they're so much less brittle. Another thing that we do that was a mistake, but that we still do, is we only run Chef once a day from cron, like between 10 and 11 in the morning. And this is related to the fact that we still have not gotten what I consider a really robust staging and unit test environment running. So we effectively rely on canarying in production. We sync all nodes to like the known desired state once a day. We do have a staging environment, and we're introducing Berkshelf, but it still kind of sucks. I mean, there are still like parts of Chef that are kind of janky where you have to both do a git commit and do a Chef cookbook upload, which is pretty crappy. Anyway, these are all mistakes that I made before hiring anyone else, so I want to make it clear that my team bears none of the responsibility for all the shit that they're trying to clean up after me for. Anyway, these are mistakes. But these are all totally solvable problems, right? Like some of these are painful, some of them are just annoying, some of them will take a long time to fix, and maybe if you're a startup, you just kind of consciously make the choice that we're going to live with this for now. But what isn't? Like, there are times when Chef is actually not the right tool. Sometimes Chef just ain't enough. So this brings me to the next part, which, what are the things that we are actively moving out of Chef or have moved out of Chef, and why? Like, bootstrapping from Ubuntu, like from a vanilla image, sounds like a great idea. Every single time you bring up a new host, you know that all of your cookbooks work. On the downside, it takes like 30 minutes. It's just not feasible. Managing databases with Chef. A config file changes. Well, your database is going to restart. This is probably something you want to do fairly intentionally for most databases. Anyway, you can. I'll go through a lot of these in a bit more detail, but you can see some themes here, right? The suck list is really bootstrapping from scratch, anything related to service registration and discovery, managing and deploying internal software, and databases. So let's talk about each one of those themes a little bit. Yeah, like I said, it seems like a great idea. Like, you know that you can, your upgrade path from like 12.04 to 14.04, if you've been testing this every single time you bring a node up, you know it's rock solid. And AMIs, if you rely on baked AMIs, they have this tendency to drift. You know, changes get made and it's not clear what made the change or when it was introduced, but somehow, if you go back and try to run your batch of cookbooks on a vanilla image, something breaks. Also, like, we started out just launching everything using Knife EC2, which is totally reasonable when you have, like, I don't know, less than 50 hosts, right? You bring up hosts fairly infrequently, you know, maybe a couple of times a week. So doing things like, you know, auto balancing across availability zones isn't terribly painful. It's fine. But once you get up to a few thousand hosts, it just doesn't work. Like, you're constantly launching instances. It takes it's annoying. So our solution here was basically auto-scaling groups for everything. Any stateless service lives in an ASG. And we've written, because we have so many of them, we have like 50 auto-scaling groups by now. We've written some tooling on top of it to do things like, you know, we change the base AMI that we want all of our ASGs to bootstrap new instances with. You know, it'll apply it to all of them at once and version the changes. So we also bake the majority of we will occasionally do a bootstrap from a vanilla EC2, vanilla kernel just to verify that everything works. But we do use AMIs that already have most of the work done. So using AMIs with most of the work pre-applied and ASGs, we can bring up hundreds of new nodes within a couple of minutes. So next, Chef is not an appropriate repository for any kind of real-time information. You know, when you're small, you can like knife node search like covers over like a multitude of sins, and it mostly works because most of your instances are up most of the time. And don't get me wrong, Chef for real-time data, totally a step up from Git in every way, shape, or form. But for real-time information, you need real-time data. Now, we use Zookeeper for this. Zookeeper itself is rock solid. The quality of Zookeeper clients varies. Yeah, you know, varies widely. So if you're using a language that it is really well supported in, great, use Zookeeper. If you're not, So we're using like a kind of hybrid bunches of language. So what we ended up doing is writing an agent, like a super lightweight agent that sits on each node and just registers its existence with Zookeeper. It just holds the ephemeral node open. And we can query this list that, like we have a local file system cache that's refreshed every minute on each node, and we can query the data really easily using various tools there, generate config files with lists of hosts for each service. If you have a slightly higher tolerance for risk, I recommend using console. I really do not believe that Zookeeper is the future of service registration and discovery. I think that it's going to be gossip-based systems. etcd, God, I had such high hopes for etcd. It's written in Go, based on Raft. It's really sexy. Turns out it was written by an intern who didn't know how to write code. So I believe that it could grow into something usable, and I wish that it would, but it's not there yet. Anyway, that was kind of a detour. Yeah, real-time data, if you're running at scale, you can't use Chef for it. Another thing, internal software packages, software that you yourself are building and deploying. I do not think you should use Chef for this. Now, sometimes people will kind of wiggle around this by, most of the code that you deploy is probably written by the software engineers. You have some sort of release process that involves continuous integration and then, some sort of deploy tools, and you're like, yeah, why would I ever use Chef to, deploy that? And good, that's the right answer. But also the stuff that you and your ops and DevOpsy type teams are, I really believe that stuff, you should package it. It's okay to use Chef to manage those packages, but just like installing them in cookbook/files/whatever Python script, that is some janky shit. Do not do that. Even managing this with Chef is pretty controversial within my team. We're having some discussions about this. I mean, the fact is that whenever you're relying on Chef to manage software versions, you are also relying on everything else that Chef is doing to execute perfectly in order to get out a tiny little change. And that is A, annoying, because it takes a long time, and B, it's breaky, and if you need to deploy something really fast, you really don't want there to be 50,000 other dependencies, Like, the fucking deb repo will be down, or just something that will prevent your change from getting out exactly when you need it to. Yeah, deploying software, you really want the absolute minimum set of mutations, minimum set of complexities and dependencies, and that pretty much rules Chef out because it's all about dependencies and complexities. So I'm going to say this. Chef sucks for databases at scale. Now this one kind of deeply, it hurts me personally. I sunk so much time to that fucking sorry, I curse a lot. I spent so much time making the MongoDB cookbooks work. We upstreamed like the EC2 RAID AWS cookbook. I had Dan. I thought it was beautiful, and it was like it was great until we got above like 10 replica sets. And at that point, the cracks really started to show. Now we still use Chef for configuring MySQL, which we use pretty minimally. For Redis, which we have like 6 clusters, but they rarely change. We started out using Chef for Cassandra and Mongo, and we have backed away from using it for both. For Cassandra, we have a 48 node, one 48 node ring, and one 24 node ring. And we use Preem to manage this. Preem is the sort of orchestrator or whatever you'd call it from Netflix. It's sweet because it handles all of your incremental backups to S3 constantly. It runs literally in an auto-scaling group. This is the only database that I've ever seen successfully run in an ASG. A node dies or you shoot it in the head, a new one pops up, it sucks down all the data from S3 and from its neighbors, and it joins the ring, and it's like magic. I did write a Chef implementation of Cassandra where you were literally like managing token ring assignments through attributes, and it was disgusting. Pardon me. Back to Mongo for a moment. Some of the problems that we started to find with running Mongo databases at scale, and let me just, I gotta just tell you, like all the shit that I did with Mongo for cookbooks, like you'd spin up a new node for the replica set, right? And it would pull down the latest set of completed snapshots for that replica set and join the cluster, and it was amazing. I was like, a MongoDB node dies, I have a single command to replace it. But we had to disable automatic restarts because whenever a config file changed or something weird changed, somebody accidentally left a space in the config or commented something out, like it would bounce the database. And that's not good because as soon as you've disabled automatic restarts, then it's not going to restart when you want it to, so you have to do that by hand one way or the other. We still had to log in and manually perform things like elections because there's not really a really good way of orchestrating things across multiple Chef nodes. Things like the priority, the hidden state or whatever for the replica sets, you couldn't store them and version them anywhere. Backups definitely worked, but they had a certain amount of manual labor involved. Like you had to say, well, this is going to be my backup node, and these are my volumes. Rebuilding nodes to increase the storage capacity was painful. Like you want to grow it from, say 6 to 9 terabytes. Well, okay, so you have to stop a node, provision a new, 9 terabyte volume by hand, rsync all the data from this one to this one, mount it, catch back up, unmount this one, unassemble the array, delete those volumes. Warm-ups are super manual. Anytime you provision a new node, you had to run a script to pull down all the blocks from S3. So I think that if you're running a database cluster or less than a dozen, and you don't need to make changes a lot, Chef is probably fine. If you're fine with having to SSH into databases and execute commands from time to time, fine. If you really need to run databases at scale, you need database-specific tooling. You need tooling where you can say, all right, go out and safely upgrade 50 replica sets from this version to this version. You need to be able to version the state of them, especially for something like Mongo, where there are so many attributes and they are allowed to change, but you want to record when they change. So we've been writing something, I don't know if you're familiar with the Mongo Lab command line tooling, where the configs are stored as JSON and GET, and you have a command where you can generate that config and store it, and you can perform actions like, do a rolling upgrade, do continuous compaction, rebuild your volumes to increase storage space. Anything that involves a lot of orchestrating between multiple nodes, I just think Chef is the wrong thing for. We still love Chef for a lot of things. Like, there's nothing as amazing as Chef for building your base systems. You'll notice that a lot of these are actually things where we lay it down in the file system using Chef, and then we use Zookeeper to do the intelligence about it. Like for cron jobs, we use Chef to install cron jobs everywhere. But each one of them has a ZK lock. Like the cron job itself is like, get ZK lock, run this cron job. So only one of them can run at a time. Another one is like managing elastic IP allocations. This is how we did the EC2 Classic to VPC migrations. We have custom IP blocks, and node bootstraps, and it asks Zookeeper, hey, what's my IP supposed to be? And then Chef applies that and updates Route 53. Monitoring configs, like, I really wish there was a better answer for monitoring in the cloud than like Nagios and Ganglia, something that would like detect when nodes are deleted. But you know, since we're using 1990s era technology for monitoring, Chef does all right for that. And the base roles thing is really fine. It's fine to use roles as long as the only thing in your role is the top level wrapper cookbook for that role. Nothing else. Yeah. Totally fine. We learned that lesson. For real time, use Zookeeper, console, etcd, something that's designed for real time. Use it for internal software, use like real grown-up deploy tools. And for databases at scale, there is nothing that can replace actual tooling. And this is my conclusion. Chef is really a great tool. I really believe that it is the best of its breed. But system configuration tools are not, sadly, magical pixie dust that you can just sprinkle on infrastructures to solve all your problems. So that's all I have. Any questions?
So if anybody has questions,
what's your feeling on running a Chef server versus using Chef 0 and like putting your cookbooks in S3 or getting everything directly from Git at runtime?
That's a really interesting question. We have always used hosted Chef because at first it was just me and I didn't want to run a Chef server, and then we got bought by Facebook and we had oodles of cash. Money, it solves lots of problems. It's kind of fabulous. Facebook actually uses the latter, though. They use Chef 0. They store the list of cookbooks in their equivalent of Zookeeper because they literally have so many nodes that there's no way that they can store state for those nodes or roles or anything. So it's not something I've played around with a lot, but we're going to be migrating into the Facebook data center over the next year or so I think we're going to get a lot more familiar with it. Yes, actually, this is one of the mistakes that we have been correcting. We had an intern this summer, and we're like, hey, intern, we have a super fun project for you. And he converted all of our forked cookbooks to use Berkshelf and the correct remote repositories and wrapper cookbooks. Yeah, it's great. I would say that we're like 66% of the way through that conversion. Like we've not drunk all the Kool-Aid, but we're like, that's definitely where we want to be. We have done the Git aspects of it. We just haven't really committed to like really reliably versioning for every single update.
How are you versioning your encrypted data bags?
Not at all. With Git, I mean, besides Git, but It's not really the same. Yeah, we're trying to get out of the data bag business. Do you have? What can we use for encrypted shit? Yes.
Hey, Citadel is a thing you can use.
Citadel?
Yeah.
What's that?
Think of it. Stores secrets in S3 using IAM roles for
Hmm.
controlling access.
We are not going to be able to use
They're moving out of
S3 anymore.
Otherwise, there's a thing on my. If you just search for chef secrets, you'll find my blog. There's a summary of all your options.
Oh, that was you. I read that
Fabulous.
blog.
Make a note of that.
Yeah, well, yesterday. Mostly for encryption management, S3 does. See how the APIs look like.
Any other questions? Sorry, didn't mean to
The data bags also make it just like really hard to run tests.
Set faults is an option if you don't use autoscaling groups. Use autoscaling groups, so
Go ahead, Lockie.
Hello. How did you solve your software deployment problem if you took it out of Chef?
I want to be clear that it was never in Chef.
Okay,
that was a break that we backed away from. So in the Ruby world, we started out by using Capistrano because A, we didn't know any better, and B, it's Ruby. Like, it was built for that to the extent that it was built. Capistrano is a terrible piece of shit. Anyway.
You're welcome.
So as we've been migrating services from Ruby and Rails into Go, we first monkey patched Capistrano to support Go binaries. Yeah. So basically, our deploy workflow right now is we have continuous integration in Jenkins. Every time the build succeeds, it tars the artifact, uploads it to S3, tagged with the get version number. And we have a thing called auto deploy that runs on every node. And it has an identity, and it pulls down the latest tarball for its identity, unpacks it in the file system. And then we were using Capistrano to handle nothing but rolling forward and rolling back. We've replaced it in the last couple of months with a really cool little piece of deploy software that I'm trying to get my guy to open source and give a talk about, because it has an agent that runs in each node, registers itself as zookeeper. This lets us deploy multiple targets to the same node. Like if we want to deploy the API server and this cool logging binary, we can just put them all in a JSON blob, and then they run this thing. They're like, oh, I need to download these things and unpack them. And then we have a really lightweight little CLI that does nothing but, like we were using Capistrano for, just to roll forward or back or to a specified get tag.
Are your environment-specific attributes stored inside that artifact, or are they stored inside some other repository?
They are stored inside that artifact. Yeah, so we bundle and deploy configs with the code.
Okay. All right, thank you.
Yeah.
It sounds like you use Zookeeper for a lot of your things. Do you have just one mega Zookeeper cluster for everything? Do you
Yes, we
have
do.
like one big prod one, or do you have dev and you have different ones for that? Or do you do Chroot, and how do you handle multiple data centers? Do you have just one region?
We just have one region right now. We're just in US East. And when we move to Facebook, we will be using their Zookeeper-esque type thing, SMC and Zeus. We use Zookeeper extensively, but it's in kind of a non-traditional way because we have tended to use languages with really shitty driver support. So we rely on little daemons written in languages that are actually supported to fetch the state of the world and lay it on disk for our services to read the configs.
What languages are those?
Which ones are well supported?
Are not well supported?
Not well supported, pretty much everything. Well supported, Java, hands down, because that's what it was written in, but who wants to use Java, right? Python is pretty well supported. The Python library is pretty solid. Does anybody want to, is anything else well supported? No, I don't think so.
There's an event machine library for Ruby that's not terrible if you happen to be using event machine,
Mm.
which means no one.
Yeah, we tried several Ruby drivers, and they just they would do these things so in Zookeeper, you have the ephemeral node, right, which is supposed to be hi, if this ephemeral node is here, it means this machine is alive. Well, with the Ruby client, it would there would be some network interruption, and it would die, but it would still be there, and it would try and connect again, and it would be no, you already exist, and so that host would just forever would tell people to connect to it, but it was never available.
Any last questions? Cool. Well, thank you, Charity. This was awesome.
My pleasure.
Appreciate it. And just to remind everybody, we all are always looking for guest speakers. As you can see, we kind of got the meetups thing down. We're getting pretty good at it, and we love hosting people. So where did he go? Talk to the blonde man in the back. So say hi to Alex. Or any of us who are not wearing name tags. And feel free to hang out for a bit, and we'll see you at the next meetup.